recorded me, it just records. Yeah. All right, so we're going to learn about derivative of inverse trig function. So if you remember, y equals inverse sine of x. That's an inverse trig function. You remember what an inverse trig function is? Whereas, I'll kind of draw a picture a little bit. An inverse trig function is something, so if we have y equals, that's not very good, but say we have y equals sine of x, that's not a very good sine curve, but it goes to 0, 0, right? So at pi over 2, what sign? At pi over 2, what sign? 1, okay? And at negative pi over 2, sine is negative 1, right? So if you remember, inverse sine says, so the inverse sine of negative pi over 2 is, inverse sine of negative pi over 2 is negative 1, okay? So that's saying what is the, that's wrong, okay? That's wrong. The inverse sine of negative 1 is negative pi over 2. It's saying what angle has a sine of negative pi over 2, right? Okay, so, and if you remember the inverse trig functions with sine, we had to restrict the domain. It kind of looked like this, where it went from, it went like this, from negative pi over 2 to pi over 2, right? And we restrict the domain. You can only plug in values between negative 1 and 1 for x. If you do bigger numbers than that, you get out an error, right, on your calculator. So it turns out that if this is a smooth function and doesn't have any places where the slope is 0, then this function is also differentiable. Okay, there's a theorem in the book that says if this function is continuous and doesn't have anywhere in an interval where its slope is 0, then its inverse function is also differentiable. Okay? Don't worry too much about that. Okay? So how do I find the derivative? So they say they want to find d dx of inverse sine of x. So this is what you want to figure out. And probably the best way to do this is to learn how to do a couple of them and then just kind of memorize the formulas. You only have to memorize 3 formulas. Okay? And so, so the way they do it is by saying that this means, if they say that y equals inverse sine of x, means that sine of y, and they don't do this the same way in this book as I've seen it in other books. I kind of am familiar with the way I've learned and taught it, so I'm going to do it this way. Sine of y equals x, okay? Which is kind of what I explained here. Sine of negative pi over 2 is equal to negative 1, right? Okay? And so to find the derivative of this thing, what I can do is to find the derivative of this thing, what I could do is do implicit differentiation on this. So what's derivative, what's d dx? D dx of sine of y.
Cosine of y times y.
Very good. Cosine of y times y prime, which I'm going to call dy dx. Okay? What's the derivative of x? 1. So I get cosine of y dy dx equals 1, which means that dy dx has to be equal to what? 1 divided by cosine y. Now I'm going to draw a picture. And in this book they don't draw any pictures, but I like this picture method. Okay? It's a lot easier to visualize. If this is your angle y right here, and sine of y equals x, What's sine equal to? What over what?
Opposite.
That's a we're in math class. Okay? Opposite over hypotenuse. How do I find this side? Why? Because if sine of y is x, and this is angle y right here, right? Opposite over hypotenuse. X over 1. By the Pythagorean theorem, what does this side come out to be? What does that side come out to be? The square root of 1 minus x squared. Is there anyone who has trouble seeing that? Square root of 1 minus x squared. This squared plus this squared equals this squared. So if I go 1 squared minus x squared and take the square root of it, I get 1 minus x squared. Okay? So now what I do is I look at this expression for dy dx. What is the cosine of y in this picture? What's cosine? What over what? Adjacent over hypotenuse. So I get that dy dx is equal to 1 over square root of 1 minus x squared. That's the derivative. Because it's 1 over the cosine of y. Cosine of y is square root of 1 minus x squared. Okay? So that's the formula for the derivative of inverse sine of x. So the derivative of inverse sine of x, you should probably write this down. I'm going to give you 3. What? I did it right. 1 minus x squared. Okay? So now we're going to do tangent. You ready to do tangent? And I'm going to skip secant and cosecant and cotangent and cosine, and I'll show you why. Okay? So, so for tangent, I'll go back if you need that. So you want y equals inverse tangent of x, and you want to do the same thing. So you want the derivative of this. So this means that tan of y equals x, right? So I'm going to take the derivative of tangent of y. What's the derivative of tangent of y? Come on. Secant squared y times the derivative of y, which is dy dx. I'm going to call y prime. What's the derivative of x? 1. And so I get that y prime is equal to 1 over secant squared y. So then I'm going to draw another picture over here. And I might ask you this, show how you would derive the formula for the derivative of inverse tangent of x. What are you looking for? I'll figure that out. Thank you. Muirfield College, what college is that? Who's this? Lily? I don't know where that is. What college? She doesn't know. If you want to go, you go. All right. So tangent of y equals x, so you call this y. Tangent is the opposite side over the adjacent side. And then if I do Pythagorean theorem, what do I end up with for the hypotenuse over here? Square root of 1 plus x squared. And secant is the reciprocal of cosine. So if cosine were 1 over this, then secant is going to be this over 1, right? So what I have is y prime is 1 over square root of 1 plus x squared. It's secant squared, so I need to square that. So this comes out to be a very nice, neat 1 over 1 plus x squared, like that. Okay? So that's the derivative of tangent. So I'm not going to do all these, so here I'm going to list all 6 of them. Okay? So the first one that we learned was ddx of inverse sine of x is equal to 1 over the square root of 1 minus x squared. Yeah, ddx of tangent, inverse tangent of x is equal to 1 over 1 plus x squared. Okay? Turns out that d dx, if you did it, of secant inverse of x is equal to 1 over, this absolute value sign comes from the domain of secant of x. So if you simplify, if you try to solve it, you get 1/2 was x times this thing, the other half is x minus this thing. So essentially, what you get under the square root sign, I'm going to look up again. Is it 1 minus x squared or x squared minus 1? I'm looking at my notes now. Is x, absolute value of x over x squared minus 1, like this, okay? And again, these can be derived relatively easily other than the absolute value sign, which is kind of tricky. You'll end up with 1 over x times the square root of x squared minus 1. So now the co-functions, d dx of inverse cosine of x, all you have to do, this is sine, cosine, is you just put a negative up top, okay? 1 minus x squared. d dx of cotangent inverse of x is equal to negative 1 over 1 plus x squared. And d dx of the cofunction of secant is cosecant inverse of x is equal to negative 1 over the absolute value of x times the square root of x squared minus 1. And you should be able to derive a couple of these, and then kind of, once you know these two, you can figure out these two, you just flip the turn in negative. And once you know this one, you can figure out this one, okay? And the other thing, sometimes in the book, instead of calling this inverse, they call this arc sine of x. And some of your calculators might have, and they call this arc secant, and arc tangent, and arc cotangent, and so forth. It's just another name for the inverse function, okay? And then you have a formula that says, for the chain rule applies to this stuff. So chain rule for any trig function. So just for, I'm just going to write it for tangent. So if you have d dx of inverse tangent, for instance, of u is equal to 1 over 1 plus u squared times du dx. Du dx or du dx. Or d du of x, d dx of u. So in other words, you can use these inverse trig functions to find the derivatives of more complicated functions. Okay? So for instance, I'm going to give you the example that they have in the book. So you should know all this stuff. This stuff you should kind of commit to your brain. Somehow memorize the formulas, okay? Really all you have to know is these three, and then you can figure out these three, right? Or you should be able to derive at least these two, and this one is pretty easy to derive too. These two are easier. It's just when you take the derivative of tangent, you end up with secant. So anyway, okay, they're all pretty easy to derive. Okay, so now we're going to do an example problem. Sorry I have to teach you so much math, but it's my job. A particle moves along the x-axis. David, you look very excited about this. No more, please. Particle, how do you think I feel? I do this all night, and then I grade all these papers, then my daughter comes and asks me math questions. I'm like, I don't want to do any more math, please. A particle, a particle moves along the x-axis. So that at any point in time, x of t, x of time t greater than or equal to 0 is x of t equals hey, where do you think you are? At the movies? Inverse of tangent of t, square root of t. Find the velocity of the particle at t equals 16. All right? Could you do that? You could do it. So all you have to do is take the derivative of the tangent function. So derivative of the inverse tangent, you're going to do, it's dt, okay, x of t. I'm just going to write out what it's equal to. It's equal to dx times, sorry, ddx of x of t is equal to the derivative of this, 1 over 1 plus square root of t squared times the derivative with respect to t of square root of t. You see where that came from? I'm plugging in the formula for the derivative of the inverse tangent is 1 over 1 plus x squared. But I'm plugging in, this is like u here, right? I'm plugging in this whole function in for the x squared. So this becomes root of t squared, and then I have to take the derivative of the inside function. So what that looks like is 1 over 1 plus t. What's the derivative of t?
1/2.
Yep, 1/2 t to the negative 1/2, right? Which is equal to 1 over 1 plus t times 1 over 2 square root of t. So what's your question, Kayla?
I'm just wondering where the t, or square root of the t squared went.
Because I squared it. Root of t squared is just t. Right? Root of 5 squared is 5. Right? So I just squared the root of t. And it very conveniently turns into t. Right? And this is the derivative of root of t. And then I just plug in 16. Okay? 16, and I get 1 over 17 times 1 over 2 root of 16, which comes out to be 1 over 17 times 1 over 8, which comes out to be 1 over 136, I think, whatever the units are. Okay? Is that horrible? It's a little horrible.
A little horrible, yeah.
What? That's the final answer.
Did we get a lot harder than that, or just, I'm guessing?
Yeah, it's small velocity. So it's a particle. Yeah, it gets a little bit harder because they're going to give me another one. Sorry, I have to give you one more thing.
Only
Okay?
one more?
Yeah.
That's not bad.
Well, yeah, one more example and one more thing. So if I do inverse cosecant, these are not these are trig identities, basically. Negative sine of inverse sine of x. Inverse cotangent. This is not calculus. This is trigonometry here, okay? But you should know these formulas. Pi over 2, because you have to know these to find the tangent line in certain cases. Well, you don't absolutely have to, but it makes your life a little bit easier. And inverse cosecant of x is equal to pi over 2 minus the secant inverse of x, right? So these are a couple other things you should be aware of. So if you want to find the inverse cosine of an angle, you just subtract the inverse sine of that angle from pi over 2, okay? So for instance, inverse sine of 1/2. What's the inverse sine of 1/2? Inverse sine, what's the angle corresponding to 1/2? Pi over 6, right? Pi over 6. So if I take pi over 2 minus pi over 6, okay, that gives me pi over 2 pi over 6, which is pi over 3. Anyway, but so the inverse cosine of positive 1/2 is pi over 3. Remember that from the unit circle? Maybe you do, maybe you don't. Or maybe you just know what the inverse. So that's getting you very confused, right? So let's do this next problem, and then we'll be done. Using these formulas, where is it? Find the equation of the tangent line. Let's change colors. Last thing, and David, there's not that much homework. Find the equation of the tangent line to y equals inverse cotangent of x when x equals -1. Okay? So first of all, you need a point and you need the slope. This will go quick. So you can look up here when x is -1. So you want the inverse cotangent of -1. Do you know what the inverse tangent of -1 is? Do you remember? Remember that inverse tangent is found in this quadrant down here when it's negative. So where is tangent -1 when that angle is how many degrees? What? -45, okay? Or negative pi over 4. So this thing, so if I go pi over 2 minus pi over 4, negative pi over 4, I will get the inverse cotangent. So when x is -1, you get inverse cotangent of -1 is equal to pi over 2 minus the inverse tangent of -1, okay? Inverse tangent of -1, which, and this slogan tells us, is negative pi over 4, okay? So you have pi over 2 minus negative pi over 4, which is equivalent to 2 pi's over 4 plus 1 pi over 4, which is how many pi's over 4? 3 pi over 4. Okay? So what that gives me, it gives me a point for my tangent line and my normal line. And now I have to find the slope at that point. And so, can anyone recite the formula for for the cotangent, inverse cotangent? Derivative inverse cotangent. d dx of inverse cotangent of x is equal to negative what the tangent was, 1 plus x squared, like that. And then I just plug in -1 in there, all right? I plug in -1, and I get out -1 over 2, right? which is just the slope, is equal to negative 1/2. And now I have my point, I have my slope. I could write the equation tangent line. Y minus 3 pi over, y minus 3 pi over 4 equals the slope, which is negative 1/2, x minus minus 1, which becomes plus 1. And for the normal line, you just flip the slope over and make it positive, right? And that's how you do that. I'll post my notes if you want to look at them again. And your homework is short. Page 175. 175, 1 through 13 odd.
Is that it?
No, not quite, but almost. 23, 28, and 35 through 37.
So what's your leader?
That's 7, 8, 9, 12 problems.
So
Okay, what? And it's
Are you going to do a